All right, this is the lesson on slope, which again is something you may have learned about in grade 9. If you did, it's kind of optional, but a lot of teachers kind of bring it up. So this term may very well sound familiar. And like so many other things that we've been introduced to this chapter, this is something we will hear on and on, not only throughout this course, but future courses. Okay, so what is slope? Well, if you hear the word slope, you probably think like steepness. And that's a good way of thinking about it. Slope is the measurement of the steepness of a line. And it's determined essentially, and I'll write a few things down here. So if you want to find the slope, if you want to measure the steepness, how do you measure it? Well, first of all, instead of writing the word slope, we quite often just use the variable m to represent slope. Why m, not s? Well, it doesn't come back to English, right? S would be for English. It goes back, I believe, to Latin. That's it. It's just m is the convention of what we use for slope. But more importantly, what we do is we find, oh, that's not the marker I wanted. We find the vertical change of something, and we divide by the horizontal change. But I'm going to write a few things down here. So when we have some sort of relationship, we see how much it changes vertically, up and down, and divide that by how much it changes horizontally. And that number we get is the slope. Now, vertical change we can describe as the change in the y-coordinates. And one way of describing change, how something changes, the difference between something, without using the word change, is to show this Greek letter delta, which looks like a triangle. And so triangle y over triangle x means the change in y, which is the vertical variable, divided by the change in x. A little more importantly, though, because you may have not seen that symbol before, is that the change in y we tend to call the rise, how much something rises by. And the change in x we call run. So quite often we hear rise over run. Slope is rise divided by run. Well, how do you figure out rise? Well, the rise of something we figure out by looking at y-coordinates and subtracting them. If we know two different y-coordinates and we subtract them, that tells us the difference between them. And so I'm going to write down y2 minus y1, and that represents the difference when you subtract the values of two different y-coordinates. That's the rise. And the run, x2 minus x1, that represents the difference between two different x-coordinates. And so the last thing I want to write here is a little description of what this y2, y1, and all these mean. So this last statement only makes sense if we know where we say x1 comma y1 and x2 comma y2 are 2 points on a line or a relationship. And so if you can find 2 points on a line, if you can subtract the two y-coordinates and subtract the two x-coordinates, you can find your slope. Okay, so I've front-loaded a lot of explanations here. As usual, the best way of understanding it is to try it. Although of all these things I wrote here, I'd say the most important two things to remember is that slope is the same as rise over run. I kind of like that in many ways because it's just so quick to say, rise over run. However, if you want a formula, which I don't know if it's that helpful, but this is a good formula to remember. But I'm a little hesitant to bring your attention to this because quite often I find students over-rely on formulas, right? If we think we understand math through understanding formulas, we don't understand math. So what is slope? It's steepness. It's a measurement of steepness. And it's a change vertically divided by change horizontally. So enough talk. Let's try calculating it. I have two lines here. And so the line in red, I want to find the slope of it. Now one thing I can see that's automatically different between these two lines is the line in red is going up, the line in blue is going down. And when I say it's going up, we always look at graphs this way. And so if we look at this graph from left to right, the line is going up. If we look at this graph from left to right, the line is going down. And by convention, we always look at a graph from left to right. And so this first line is going up, and I'll just write that down here. And this line is going down. But that's not the slope. That's just describing the direction of this change. And so what's the slope of the one in red? Well, I want to pick 2 points. I can pick any 2 points I want. I might as well pick nice friendly numbers. How about this point right here and this point right here? Okay. Now I could find the coordinates of these. For example, this point is 0, negative 1. I could find the coordinates of this, which is 5, 1. I could then use that last formula I gave you. And I could say, I could call this x1, y1. I could call this x2, y2, and plug these numbers in and work out the slope. But I think that is a poor choice because in the end, I have a graph. I can count these squares easily. It is superior in terms of time and accuracy to just count the rise and the run. And what I mean by rise and the run, well, let's start over here. Oh, that's the wrong marker. Let's start over here and think, okay, to go from here to here, how much do I go up by? Well, I can just count. I go up 2 squares. That's my rise. I don't need to look at my coordinates. It goes up 2. And what's my run? What's my horizontal change? Well, I count the squares. 1, 2, 3, 4, 5. That's my horizontal change. So to go from one point to the next, I go up 2 over 5. 2 over 5, so my slope is 2 over 5. And this is a fraction. I think it's great to just leave it as a fraction. Shall change the colors. If I could reduce the fraction, I would, but it's already in lowest terms. If you want to decimalize it, you could. It's 0.4. However, this fraction I think is great to leave it as it is, because when you see slope as a fraction, you can literally see the rise and the run. So if a line has a slope of 2/5, I know from any point on the line, if I count up 2 and over 5, I will find another point on that same line. Fractions are preferable to decimals mostly when we're dealing with slope. So let's look at this one. It's going down. So let me pick 2 points. I don't know, how about this point here and this point here? Okay, and again, I always want to go from left to right. And so going from left to right, I'm going to first find the rise. And this time it's going down 6 units if I look at these points. So my rise is -6 because it's going down. My run, how far over this way, is +2. And so my slope is -6 divided by 2. However, in this case, I really should reduce that because -6 divided by 2 reduces to just -3. And that is simpler. Now notice my slope here is negative, which we'll always notice when a line is going down. When a line is going down, the slope will be negative. When a line is going up, the slope will be positive. And so notice, even though I showed you a lot of things here, this formula right here, and you even use it, unless counting squares isn't so helpful. Or maybe I don't give you a graph. But by default, please don't go to that formula. Slope is rise over run. It's a relatively simple thing to calculate if you have a nice visual, which so far we have. Okay, let's look at these 2 examples here. A vertical line and then this other line to the right. So the vertical line, well, let's find the slope of this. I'm going to pick 2 points. How about here and here? Okay, so now this time it's kind of weird. My 2 points are on top of each other. So my rise, I'll go down, I guess, is -3. So my slope, the rise is -3 over the run, the horizontal change. Well, the horizontal change is 0. These 2 points are on top of each other. There is no horizontal change. So it's -3 divided by 0. And what is -3 divided by 0? It's not 0. If you type it into a calculator, it gives you an error. You can't divide by 0. Division by 0 doesn't make sense. This means take the number -3 and break it up in the groups of 0, of no size at all. You can't take a number, I don't care if it's positive or negative, and break it up in the groups of 0. And so this is not possible. A calculator will give you an error. So we don't write not possible, we don't write error, we say the slope is undefined. Anytime you divide by 0, it's undefined. There is no number for it. You can't describe the slope of a vertical line with a number because you're dividing by 0. And so anytime you have a slope that is undefined, we know we're looking at a vertical, purely vertical line. All right, so what about this one here? I have this purple line. And so you may be tempted to look at this and look at this square point here and this point here. Great points to look at. However, if I count down 2 and over 3, there's a problem here. And that's because if I look at my x-axis, each of these squares is not one whole. For example, that's 20 right there, which means I know that each of these squares represents 5 units over. And so, yes, it's 2 grid lines down and 3 grid lines over, but if I look at my scale, my slope is a little different. It's 2 down, because I look at my x-axis, it goes from 0 to 5 up here. But my y-axis is going in 5s, so those 3 squares actually represent 15. And so my slope is -2 divided by 15, which is already in lowest terms, so I'm not going to do anything more to it. Notice it's again a negative number for my slope, and we could tell right away the line was going down. It's really easy to miss that negative there sometimes. Okay, and it's really easy to miss the scale of a graph. And we always want to pay attention to the scale of a graph, obviously. All right. So for these two here, it's kind of the other way around. I want us to draw or graph a line with just what I give you right here. And what do I tell you? For each of these, I tell you that a line goes through this point. In this case, for this first one, -2, 1, and has a slope of -2. So just from those two things, I can visualize this line with great accuracy. So how do we do this? Well, let me get a ruler ready. Rulers are great things for drawing lines. OK, first thing I want to do is graph this point, -2, 1. I know this line goes through -2, 1. So where is -2, 1? Let's plot it. 2 to the left, 1 up, right here. So there's that point. I know my line goes through that. So it goes to that point and has a slope of -2. So now what does a slope of -2 look like? Well, I know my line's going down. So I know my line is going to look something like this, for example. It's going down. But how steeply is it going down? Is it like this, or is it like this, or is it like this? What's happening? Well, I know it's going down, but let's look at the slope now. My slope is -2, which if I take my slope and write it as a fraction, I haven't changed it. -2 and -2/1 are the same. But now it makes it more clear that -2 is the rise and 1 is the run. Which means a slope of -2 can be visualized as picking a point, which I've already highlighted, and from there going down 2 over 1. So notice if I go down 2 units and over 1 unit, I have another point. And really, that's all I need to visualize a line. I just need 2 points. That's it. It was pretty easy to do that. So why don't I do that a few more times before I actually draw my line? From that point, go down 2 over 1, down 2 over 1. Or I can go in reverse. I can go up 2 and backwards 1. I mean, it's all the same line. And the good thing about lines is once you know what a couple points are, it should be pretty easy to visualize the rest. And so I got way more points than I need to draw my line. I'm going to draw it right now. There's my line. Try to remember, always draw arrowheads on it to show that it goes on forever. And there's my line. And so for the next one, same idea. I got my point, 3, -4. Let me graph that. So 3 to the right, 4 down. There's my point. This time I have a slope of 0. What does a slope of 0 look like? Well, let's think about rise over run. I can make this look like a fraction by going 0 over 1. For example, that works. And so I can see my rise is 0 and my run is 1. So what does that look like? Well, let's see. Let's take my point. Let's go up 0. Well, that's pretty easy. I don't go anywhere. And let's go over 1. OK, let's go over 1. I got another point. There we go, right beside it. And let's do this again. Up 0 over 1, or go backwards. You know, down 0, backwards 1. You get the idea that I have a horizontal line here. And a slope of 0 is perfectly horizontal, which kind of makes sense. I've already said a positive slope is going up. I've already said a negative slope is going down. So horizontal is neither up or down. It's neither positive or negative. And the only number that is neither positive nor negative is 0. 0 is not a positive or a negative number, and it's the only number that has that characteristic. All right, and so let me erase all this and get to the last question. The last question is about understanding what the slope of a relationship means if it's applying to real data. So what I have here is the population projection for different neighborhoods in Surrey over the next 30 years. Okay, so this is starting in 2016, going well into the future. And these are the predictions for how different neighborhoods are going to change in population. I want to focus on the city center component, kind of where SFU, Surrey is, and the SkyTrain goes through. So I want to focus on this point, the city center component. Okay, which is this line right here. Okay, now that prediction for the future growth of the city center is not a perfectly straight line, but it's pretty darn straight. So what I want us to do is find the slope of that line. So how do we find the slope? Well, first we pick 2 points on it. I can pick any 2 points. I'm going to pick points that I feel the most confident I know the coordinates of. So how about like, I don't know, right here, for example. I know that's at the year 2021. The population is just shy of 50,000. So I'll say, I don't know, about 48,000. I'm estimating. Another point I want to pick, how about I go right to the end? Let's look at this point right here. I know that's the year 2046. Population is just shy of 100,000. Let's say, I don't know, 98,000. Okay, so those are my 2 points. So how do I find the slope of this? I could use my slope formula, and I could, if I want, it's not a wrong idea to call this x1, y1, call this x2, y2. And in doing so, all I'd end up doing is subtract my y coordinates and divide that by when I subtract my x coordinates. So instead of actually using the formula, let me just get right to it. And let's say the slope is going to be, when I subtract my y coordinates, my vertical change, so 98,000 minus 48,000. That's my numerator. And in my denominator, I want to subtract the years in the same order. So in this case, 2046 minus 2021. If I do that, I actually get some pretty nice numbers. I get exactly 50,000 in my numerator. I get exactly 25 in my denominator. So a rise of 50,000, a run of 25, which simplifies down to a nice clean 2,000. So what does this 2,000 mean? What are the units of this number? If we know what the units of this 2,000 is, then we probably know what this number means. Okay, so what does this mean? Slope is 2,000. Well, let's look at the units. And to know the units, let's look at my fraction right here. Well, that was that 50,000. That was 50,000 people. Right? My y-axis was people. What was 25? That was years. That was what the x-axis was. So this is 2,000 people per year. And if I know the units, that probably makes it more clear what this means. This represents, this 2,000, this slope represents the average amount of people that are growing, that are being added to this neighborhood in Surrey every year. It's an average because the line isn't perfectly straight. So this means we add about 2,000 people per year on average. That's an important word there. On average in this neighborhood, Surrey Central neighborhood. The key words are, well, units, people per year, and it's an average. Okay, so we're not saying exactly 2,000 more people are being added to the neighborhood every year, but on average, that's what that number is representing. All right, and every time we look at slope of data, that number always represents some sort of average change, in this case, number of people. All right, really important lesson that's going to keep coming up, but I'm done. I need to drink some water. So goodbye.